Welcome to week 3. Now that you have a solid foundation in XML, we can move from markup languages to actual programming languages. But before we can jump into XSLT, we must first begin with Xpath. Xpath is a query language used to traverse through an XML document. It is used commonly to search particular elements or attributes with matching patterns. Without Xpath knowledge, you will not be able to create XSLT documents. Xpath stands for XML Path Language. It is a query language used to traverse through XML documents and to search and match elements and attributes. Xpath is a syntax for defining parts of an XML document, and it uses path expressions to navigate in XML documents. Xpath also contains a library of standard functions which are used to search and match elements. In this session, we will learn how to use those standard functions. Think of Xpath as a list of directions. Xpath will tell your XSLT where to look at the metadata. And since Xpath is the foundation of XSLT, we will begin using Xpath to navigate some XML examples. In Xpath, there are 7 types of nodes that will be within your XML documents. And these are structured as a tree, just like in your XML code. First, we have the root, elements, text, attributes, comments, processing instructions, and namespace. We will be focusing on roots and elements and attributes and text to an extent, but those top 4 are the most popular that will be used. You normally don't need to query your comments or namespaces. In order to understand XPath nodes, think back to the structure of XML documents. Remember the family tree structure or a branching out tree structure. Specifically, think back to how those elements are nested. Remember, after the declaration and schema, the root element follows. In XPath, the elements translate to nodes, so the root element is also your root node. Similarly, everything is true, all of that is true for your elements becoming nodes too. So you have your parent element or parent node after the root, and then after that you also have your children elements, which are also your child element nodes. And remember, pay attention to the indentation of the elements. They branch out like a tree, and their alignment will help you identify what type of element and node they are. This will be important when navigating through these, so you know how to count different types of elements and nodes. When it comes to the relationship of nodes, think back to the tree structure, where we begin with the root node, in this case a bookstore, and then the parent node, which in this case is a book. Following that, we have the siblings, which are all of the child nodes, or child elements, which include the metadata such as title, author, year, and price. Here's a similar example of nodes, but with Mark XML. Again, we begin with the root, which is the whole records collection. Everything about the collection, all of the records are stored within this element. Following that, we have the parent node, which is a single record. Then we get into the real metadata of the record, which includes the mark data field nodes, which are child nodes, which are siblings. Those will include tags, well, any of the data field tags, but in this example, we're going to use 100 and 245. And then, as we know, your child elements or child nodes can also have grandchild nodes or elements, which are subfields. Again, everything is nested properly, and it's easy to navigate, both logically and visibly. Remember to look at the indentation, again, if you are confused about what type or what number element or node you are using. Now for a quick look at nodes and some actual Mark XML code, basically a more in-depth view of what we just saw. So we have our root node up here after the XML declaration, and then we have our first parent node, which is the Mark record. You can have multiple records within your record collection, but in this case we're going to look at this single parent node, Mark record. Next we have our child nodes and grandchild nodes. And then you can see that we go back to other child nodes. So all of the children line up right here. And then if there are any grandchildren, they line up as well. And all of those are properly nested within the parent node, which is the mark record, which is properly nested within the root node of mark collection. Xpath drills down through XML elements. Now that you understand how to navigate elements and nodes, you can define the searching criteria for your XPath and XSLT scripts. To do this, you will use expressions. Think of these expressions like shorthand notes for directions or commands. Each expression character represents a different command. Once included in your code, these characters allow the computer to navigate through your XML in order to select the nodes you want. For example, you might have a set of mark XML records that you want to query. You would rely on the names and position of nodes in these characters to construct directions, telling your code where to pull the information you want. After that last slide, you were probably wondering how to use expressions or how to construct them with your node names. In this figure, you can see how the different paths are created and a description of the result if you were to use those expressions. This will be very helpful resource throughout the course, particularly for this and the next couple lectures. After that, you'll probably be used to constructing node path expressions on your own in seconds, and you won't need this anymore. It will just be common knowledge to you. But for now, keep this handy. The basic Xpath syntax is similar to file system addressing, like in command line, or if you're on Windows and you look at your path to different files and folders. If the path starts with a slash, then it represents an absolute path to the required element. So let's look at how we navigate these node paths in order to select elements or nodes. A slash followed by the name of the root element will select the root element. If you want to select a defined element within your root element, then you would include the root and then drill down to the name of the child element you want. So in this case, we want to select all of the C elements. So we start with the root and then we just jump straight down to C. You don't have to do A/B/C to drill down to that, because these are all the same type of children elements. So you don't need to drill down through them each individually. You just state the name of the one that you want following the root element. But let's say you want to select a child node from a parent node. You would structure this beginning with the root, then drill down to the parent node, which in this case is D, because we want to select all of the B elements. So we go from the root, which is A, down to D, which is the parent, which holds the triple B child element. And so we just drill down to exactly what we want. You just use a slash to separate the paths, and then your script will pull the information that you tell it to. Let's say you want to include all elements that share the same name. Instead of using a single slash, you would use a double slash. Reference the expressions figure if you want to learn a little bit more about this, be reminded about its actual definition. But here we'll have some more hands-on examples of this. If you want to select all elements that are named triple B, in this case, then you simply encode this as a double slash followed by the name of the element, which is 3 B's. So we want to select all of the B's in this, no matter where they are. So we just put this double slash, which says select anything that has the triple B. If you want to select all triple B nodes that are elements of the triple D nodes, then you would use the double slash to select all elements in the path of the triple D followed by the B. So it's going to go through any of the occurrences of the element triple D, which we have here, as well as down here. And then we tell it to select any of the B elements that are within that. So if this triple D right here had another child element called triple C, that would not be selected. The code just says to take all of the B's within D, so it would not select the C. Now that you're tired of hearing me say slash, which I'm going to end up saying quite a bit more throughout this lecture, we can move on to predicates. Predicates are similar to expressions, but they are more specific. Predicates are used to find a specific node or a node that contains a specific value. They refine or filter node sets, and the predicates are always embedded in square brackets after your slashes and node names. And they are included in, embedded in the square brackets. Sorry, I mixed these up. My timing was a little off. Anyway, here we have a little bit of XSLT that uses Xpath to select the value of some elements and attributes in a MARC record. In the first example, we see that the MARC data field 245 is being selected. In this case, we are selecting all 245 elements and any other subfields that go along with that. If you are wondering why there is no beginning slashes telling the code to select all occurrences of 245, which you might expect to be at the beginning of either of these, well, that's because this is XSLT. This is an XSLT script, not just an Xpath script. So up here we have our slash, actually in both of these cases, which are telling our code to select anything within the MARC record. But what you want to focus on right now is what is in these boxes right here. This is where the Xpath comes into play. So here we see that we're drilling down through the records, which is taken care of up here, down to the data fields, and we are using the predicate in brackets to tell our code to only select the data fields that have tag 245. So we would only be selecting information about the title of a resource, nothing else about it. In this example, we want to look at the 490 data field, which is where volume information for a series goes. Within that MARC tag, the subfield V stands for volume number. So if we want to pull the title and volume number for resources within a collection of records, this is how we would do it. Here's some more examples of predicates. You can explore these here and through your readings to get a better understanding of them. They function just like the predicates from the previous slides. All you need to do is encode the predicates in bracket after you define the file path. And here are some examples and results again. This is similar to the ones we just looked at. These ones allow you to do a little bit more. You can select specific positions, or instead of using a number to select a position, you can say you want the last one or first one. You can also specify attributes, which we just saw, or you can even do greater than and less than. We won't be using that too often. I've personally never seen that used in libraries because we're not looking at price values usually, but maybe if you're in acquisitions departments, something like this might be useful for you in the future. When using predicates, you can select nodes by name or attribute type, but you can also use predicates to select the position of an element. All you have to do is count the position you want, then put its position number in the brackets following your path. In this example, we want to select the first B node following the root. So we drill down from the root to the triple B nodes. There are a few nodes of the same name here, but we only want to select the first one. So we include the position number, which is 1. It's the first one, not the second, third, or fourth one. And we put that in the brackets. So we say go down to the root, which is A, and then go to the first child of A, which is considered B. In this example, we want to select the last B node. We want to keep the same drill down structure as the first example, in which we begin at the root, which is A, and then go to the B node, and then we specify we only want the last B node. We don't want the first one, we don't want the second one, we just want the last one. Since there are only 4 in this case, you could have structured it like the first example and put a 4 right here instead of the 1, but we can just keep it easy on ourselves and just say last. You've already learned to select positioned nodes and named nodes, but what do you do when you want to select an unknown node or multiple node types? Wow, that was a tongue twister. To do this, you can use wildcards. They will allow you to match and select by any element attribute or any other combination or type. Here we have some examples and their results. So this shows you kind of like the last examples of what each wildcard or expression will do, or how it looks, and the description of what it does, and a result of what it does when used. The star, or asterisk, selects all elements located by preceding paths. You can see over here that this wildcard asterisk matches any element node. And you can combine it with others to find attributes, or attributes within a tag as well. To select all elements within the second element of D, we have here, we would start with the root element, drill down to C, so root, and then C, and then down to D, and we want everything encoded within D to be selected. So instead of saying select B and then select E and select F, we just use an asterisk and it selects all of them. You can also use the asterisk to select all occurrences of B, no matter where it is nested. To do this, you drill down to B after defining how many ancestors there are before we start getting down to the B's, and then you get your B. So we have 3 ancestor elements. We have a root, we have a parent, a child, and a grandchild, but we only want B. So we're saying just drill down until you see B, and then we specify we only want B. And then similarly down here, we have B and some other B's. But since we said just go through everything, which the greatest amount of ancestor elements preceding B is 3, so drill down to 3, and then after we get past that, find anything that has B in it. Or maybe we want to select everything, entire copies of records or XML documents. To do that, simply use the 2 slashes. Remember, those mean select everything, and follow that by an asterisk. Since an asterisk means everything, and the slashes mean all, it means select all, select everything. So as you can see, the double slash and asterisk will copy the entire document. You can also use predicates to select the values of attributes. I'm not going to read through all of these since you can do that yourself, and I've read through the last couple slides, so now you can understand how these examples are structured. And I really like these examples since they tell you the code at the top, and then they tell you basically the goal or the problem, what you're trying to select, and then following that it has a great kind of hands-on example of it, so you can see how to actually use that code. Again, I'm not going to read through all these since I've done that for the last couple slides, but make sure you review these examples as well. Some of these might be useful when selecting mark tags. You might be familiar with the ID attribute from earlier, so just take a quick look at these two and save this knowledge for later. Finally, you can use operators and expressions. I also won't be going through this too much since we're not computing sums. This is more for mathematic equations, as you can see. But I can do a few other things like the greater than, equal to, less than, all that. That might be helpful at some point. Also, the computes to node sets might be useful for you as well. But we're not actually going to be using these anytime soon. You might choose to use these for future assignments and projects, but you really don't need to know this part. These operators aren't something that I typically use in my metadata work, but I just wanted to let you know that they do exist, and now that you know how to use other expressions, they'll be easy for you to incorporate into your own code. Now you try. Here are some examples of using Xpath to select certain elements. The first slide will show a question with code, and then the following slide will provide the answer. Remember, there can be multiple ways to select nodes. There are multiple ways to have correct code. The following are examples of the most simple and specific ways to select nodes in these instances. This is how I would do it, and since we're all starting out here, these are kind of the best way to do these. So for example 1, use Xpath to select all MARC records that belong within the MARC collection. So there are, well, here's the solution over here. We can use the double slash, because remember, that means select all, and we want everything within the MARC collection to be selected that is considered a MARC record, because we are selecting all MARC records. So we would start with the root, which is the collection, and then drill down to record. And then we want all records, so that will select all records. For example 2, we want to use Xpath to select all instances of the element MARC data field tag 245. And that's a typo right there. That's not part of the problem. But as you know from earlier lectures, this should be either both single quotes or double quotes. So I apologize for that. Anyway, in order to select all instances of the element MARC data field tag 245, we could use the double slash to go down through everything within the collection, which is the root, and then we tell it to look at the records, and then we tell it to drill down into the data field that has the attribute 245. And then anything that is encoded as a 245 will be selected, which in this case would be this whole section, Moby Dick and its author, Herman Melville. In this case, we would be selecting the 245, which is the book Paradise Lost by John Milton. In order to do that, we have our tag defined here, and you would only get the 245s as a result for the code. Wouldn't get the records or anything else, just the 245 that you have specified. Here's another kind of faster way to do it. You can just jump right down, bypass the collection, and go down to the data field in the tag. And that's because you're using the double matching. It will just go through the whole record and pull the 245s. You don't need to deal with the nesting in this case. But since we're starting out, it's good to be able to trace back your node path. So I like to look at the indentation and then just literally drill down. So I just go in order. That's the easiest thing to do. It's not the shortest or most concise, but it's really easy to keep track of where you are this way. So for example 3, we want to use Xpath to select all instances of the title element subfield code A. So we just want the title. Remember, 245 is more than a title. It can also include information such as the creator, like the author, or an editor. It can also have subtitles, volume information. But in this case, we just want subfield code A, which is the title. Since we want to select all instances of the title element subfield A, we drill down from the root to each record and then down to the data field tag 245. But we only want the title, so we have to specify we only want subfield A for all records. But since we want all records, we need the double slash. And then we finally find ourselves at code A. Since this is in brackets, once again, we know that this is a predicate, and this is specifically defining that we only want code A for the 245s throughout this entire record. Another way to do it is to just jump down to the 245 and say that you want A. If you wanted to get very technical, this is just for an example, you can drill down to the data field tag 245 and then say that you do not want subfield C. Since we only have A and C in both examples, you would get the result of A because you want everything except C. So this is just to show you how to use one of the not certain attribute predicates. That is not the best way to do it though. That's just to show you how to do it though. So if you are confused, if you're confused, don't worry. This will all make more sense next week once we apply Xpath and our XSLT. Just keep reviewing the lecture and the readings, do the quiz, and let me know if you have any questions. But remember, the important thing to learn from this lecture is how to identify node types, how to navigate node types, and the meaning of symbols such as the slashes and the asterisks. And remember, when working with code, there are many possible solutions. It's possible for some students to write a short, concise script for a problem, while other students write longer scripts. I'm simply giving you the tools to build your own solutions. And for the future, as you saw from some of these examples, we will be able to incorporate the XSLT with the Xpath, and then you'll be able to do your queries and transform your metadata in the next couple of weeks. So now that you understand everything, you can move on to the quizzes. And once again, let me know if you have any questions, and also feel free to use the question discussion post section.